Okay, the last section in chapter 6 is 6.6 on investment portfolios. So what the heck, let's go all the way down here to where it says investment portfolio. What is an investment portfolio? Basically, it's a collection of investments held by an individual or organization. So in other words, you as an investor, maybe you have a savings account, a checking account, and you've got some money in RESPs, and you have a property, a house that you own. Whatever, all those things make up your investment portfolio. And then some of the terms that go along with that, we'll just quickly breeze through this. An annual rate of return. It's based on the income received during a year compared with the investment's current market price. So for example, let's say that you could buy a bond for $500. We'll talk about bonds in a second. Let's say you could buy it for $500, and that the annual rate of return, the return you can expect after 1 year is $50. Well, if you divided 50 by 500 and turned it into percent, you'd get 10%. So that means that your annual rate of return on this bond would be 10%, which would be very good indeed. Okay, the average annual rate of return is just if you look at what your annual rate of return is over multiple years, you can get your average annual rate of return. So maybe in like a savings account, let's say, 1 year things are going really well and you get 8% rate of return, and then the next year, let's say it doesn't go so well, you get 4% rate of return, and the year after that it goes even worse, you get 3% rate of return. If we want to get the annual rate of return, we'd add all those up. 12 plus 3 is 15. Divide by how many years there are, 3, and 15 divided by 3 equals 5. The average annual rate of return is 5% over this 3-year period. Each one of these is an annual rate of return. This is the average annual rate of return. Okay, depreciation. Something's depreciating, it's getting lower in value. So it's the rate at which the value of a property or item is reduced. Average rate of depreciation is the average rate of reduction over multiple years, just like what we talked about up here. And zooming along here, appreciation is when the value of a property or item is increased, things are going up. Average rate of appreciation, we just take the average over multiple years. So there you go, cruise through that, and let's get to our one question. One final question in this course, and man, is it ever a doozy. So this will take quite a while. Hopefully I can keep the video under 20 minutes. I'm hoping so. It says, Jason and Malik are each hoping to buy a house in 10 years. They want their money to grow so they can make a substantial down payment. Whose rate of return is greater? So we've got Jason's portfolio and Malik's portfolio. Let's start by going through Jason's. So Jason has 3 things in his portfolio. He has a 10-year $2,000 GIC. A GIC is a guaranteed, I should have written this, it's much faster to type it beforehand. It's a guaranteed investment certificate. There we go, guaranteed investment certificate. And these are things that are guaranteed, as the name suggests. So they're very low risk. You know you're going to get that money unless the bank defaults or goes under or something, very unlikely. And because they're low risk, they're also fairly low return. So in this case, you get a 4.2% return. So there you go. He also has a savings account. You know what a savings account is. And that earns 1.8%. And he's also saving $55 every week in that. And then he also has a 5-year $4,000 bond. What's a bond? Basically a bond's kind of like an IOU. You know, an IOU, right? When you tell someone, oh, I'll cover me today with this money I need, and then I owe you a certain amount of money. It's like that, but what you're actually providing an IOU for the government or for a corporation. So you lend your money to the government or a corporation, and then they tell you, okay, we'll pay you back in however many years, but we'll also tack on some interest. Again, fairly low risk. Okay, Malik's portfolio, she has a tax-free savings account, just like the name suggests. Tax-free saving account, there's no tax. The income you earned is not taxed, and even better, even when you withdraw the money from your tax-free savings account, it's still not taxed. So that's different than RESPs and RSPs, which when you withdraw the money, you get taxed on it, but not while you're accumulating the money. This was just introduced into Canada in the 2000s, I think around 2006 or something like that. So we've got all the details there, and she has a Canada savings bond, so it's just like the bond up here, but specifically to do in Canada. And finally, she also has a savings account. I'm not going to read every word here, it's going to take all day. So basically, we're going to go through and figure out, the question, remember, was who has the greater, whose rate of return is greater. So the first thing we better figure out is how much was invested. This is so annoying because I'm going to have to go back and forth, back and forth. I'm probably going to stop doing that after a while. So Jason has 3 investments. He has his GIC, he has a savings account, and he has a bond. So let's see how much each one of those ones was. For the GIC, it was $2,000, and for the bond it was $4,000. So let's put those ones in right away. $2,000 and $4,000 down here. Now for the savings, it's a little bit more complicated because he's putting $55 in every week. Okay, remember this is over 10 years. So $55 a week. There's 52 weeks in a year, and we're doing this over 10 years total. These ones, the 2,000, the 4,000, you're buying those things, putting that money in, and you never put any more money in after that. But with the savings, you're doing it every single week, and he ends up paying that much money. So if you add all those amounts up, of course you have to multiply this first, but if you do that, you're going to end up that he has invested $34,600. Okay, Malik has also got 3 investments in her portfolio. She has her TFSA, the tax-free saving account. She has her Canada savings bond, and she has also got a savings account. So again, let's take a look at how much those are. The TFSA is $5,600, and the Canada savings bond is $500. But that's 500 every year, so that's going to be 10 times 500, right? So this one was 5,600, and the Canada Savings Bond was 500 per year, but it's over 10 years. So we've got to do that. And the savings account, she saves $200 every month. So $200 every month. There are 12 months in a year, and it is over 10 years. If you multiply and add all that, you'll get 34,600. What do you know? They've put exactly the same amount of money, invested the same amount of money in their investment portfolios. So now it's time to look at who's made the better decision. Okay, I'm very sorry about this, but we're going to have to use our graphing calculator over and over and over here. So the first thing we're doing is with the GIC. Okay, I think I'm going to go back to the previous page to get all the information. So we go down here, we're looking at the GIC, which is right here, and we're going to use our graphing calculator a lot here. So here we go. Go to number 1. And let's see, it's 10 years and it's compounded semi-annually, so that's 10 times 2 is 20 times it's compounded. The percentage is 4.2. The previous value, present value is 2,000. Remember, we have to put negative 2,000 because it's investment. The payment is 0. We're not making any payments, and it's compounded semi-annually, so that's 2 and 2. And if we go back up to future value and hit alpha enter, we get $3,030.71. Okay, so let's put that in here. $3,030.71. Let's go back and do our savings account. Okay, so now we're on to this one, and we'll go to our calculator again. Okay, this time it's compounded weekly, so it's going to be, for our number up at the top there, it's going to be 52 times 10, which is 520. Our percentage is now at 1.8. Our present value is 0. We're not starting with anything, but there is a payment. The payment was $55 a week. I don't think you can see that right now, but trust me, it is $55 a week. The future value we don't know. I'll just put a 0 there, and it's compounded weekly, so it's going to be 52 and 52, back up to future value, and if we do that, we get 31,329 and 72 cents. 31,329 and 72 cents. And finally we have to do the bond, and this is worst of all, because if you read this one carefully, we actually have to do it twice. It's taking forever, so let's go to the graphing calculator. This time it is compounded quarterly, but it's only a 5-year bond. Compounded quarterly, 5 years, that's 5 times 4, so the N is going to be 20. The percentage is 3.9. The present value is 4,000, but again, we'll make it negative 4,000. The payment, there is no payment. Future value we got to figure out. It's compounded quarterly, so that's going to be 4 at the bottom here, and we get our future value, which is $4,856.65. But here's the thing: he's going to reinvest that money in a different bond, and this time the interest rate is 4.1. So we're just going to go ahead. It's still going to be another 5 years, so the N value is still going to be 20 because we're doing an additional 5 years. But now the percentage has gone up to 4.1, so that's a little better. And the other thing that's a little better is instead of having $4,000 to start with, we're starting with that 4,856. So 4,856.65. And this is what we want to know. So again, we'll go alpha enter, and we end up with our final amount from the bonds, which is $5,955.44. So let's write that in. $5,955.44. All right, now what we want is the total value. So in order to get a total value, of course, we're going to add those three things together. And if we do that, we're going to get $40,315.88. This is how much Jason's portfolio is worth. And remember that how much he invested 10 years ago was $34,600 total. Should we get the total rate, or the rate of return right now? Why not? What we do for the total rate of return is we see how much interest he's gained, or how much return he's gotten. So that'd be the difference between the 34,600 and the 40,315.88. So let's do that first. We'd be going 40,315.88 minus 34,600, and then we would divide that by how much he started with, how much he actually put into the portfolio, which is 34,600. Turn it into, well, first of all, you get a decimal, which is 0.165, or as a percentage, it's approximately 17% if we round. That's a very nice rate of return for Jason, 17%. Good job. Now we do the same thing again, but this time we do it with Malik's numbers. So we'll start with the TFSA down here, and we're looking at this one. Whoops, should have used yellow, but who cares? No time, we gotta go fast here. So what's she doing here? Compounded monthly, so that would mean over 10 years it'd be 120, 12 times 10. The percentage is 2.2. She has a current balance of 5,600, so I'll put negative 5,600 in there. No payments. We'll make this 0, and it is compounded monthly, so it should be 12 and 12. And we'll see how much that TFSA is worth after 10 years. It's worth $6,976.62. So that would go, where are we here? Down here. She has got, let's use a different color for her, blue, $6,976.62. On to the Canada Savings Bond. So that is this one. Okay, bring up the graphing calculator. Compounded annually for 10 years, so that means their N value is just going to be 10. And the percentage is 3.6. The present value is 0, she has nothing, but every year she's putting in $500. So you should have negative 500. and we don't know the future value, and the payment per year and compounding per year is 1. So if we do that, we will get $5,892.88. $5,892.88. We're almost done. We just have to do the savings account, and don't worry, there's only one thing we have to do, not two like we had to with Jason. So this one here, bring up that graphing calculator, and what do we got? It's compounded monthly. So monthly over 10 years, that'd be 10 times 12, which is 120. The percentage is 1.6. Now what's she doing? She's starting off with no money, and she's putting in every single month $200. And the payment per month, it's compounded monthly, so it's going to be payments per year is 12, and same with compounding per year. Go back up here and put alpha, enter, and we get $26,007.87 for our final number. $26,007.87. For our total, we're going to add those three together, and if you do that, you'll get $38,877.37. And what we want to know is what's the rate of return. So we take how much she ended up with, $38,877.37, subtract how much she invested, which was the same as Jason's, $34,600. That would leave us with how much more money she has. If we divide it by what she started with, that'll give us the rate of return. And if you do that, you're going to get 0.123, which is basically approximately 12%. So the winner in this case is what the whole question wanted us to ask. Who has the better rate of return? It's Jason with his 17%. Well done, Jason, and well done, Foundations 12 students. You've made it to the end of the course. I congratulate you, and man, it was really fun to teach you. Have a good summer.